Welcome to our first lecture on artificial intelligence. So we will talk about the basics. How do we define artificial intelligence? How did artificial field of artificial intelligence arise? Of course, there is quite a bit of history behind it. Now, as far as technical issues is, again, I assume most of you have access to Ortus now, hopefully all of you, right? So we will be following the following notebook, right? Here, Google Colab. Again, if you have access, you can clone the repository. Again, you can clone repository from here, from the course GitHub repository, and you can open up and do it at yourself. Right here, the link is here. Now, and of course you can clone it as usual, right? Code, you know guys how to do it, right? But I will be using Google Colab for this particular lecture since I am traveling. I will again reminder that on Thursday we meet in person. Now let's get started. So the book is called Artificial Intelligence: A Modern Approach, right? How do you say what's an ancient approach, right? By Berkeley. It's published in Berkeley. Again, Stuart Russell, Peter Norvig, both very accomplished. Again, Peter Norvig is the head of AI at Google, at least used to be. Quite a good programmer himself, right? He has some really nice code out there, right? So let's get started. So how do we define it, right? What's human intelligence? Again, I'll be skipping it. I recommend you go over this notebook in more detail before Thursday, right? So I will be going through the key parts. Now, we sort of think of ourselves as intelligent, Homo sapiens sapiens, right? Actual name for us, right? We want to think, and also we want to understand how we think. And it turns out it's actually not so simple, really. Our brains, which only, how much do they consume? Only about 20 watts or 75 watts, right? Quite a bit less than the current AI state-of-the-art models, right? We are able to have amazing ability to perceive our world, how to understand this world, and also, well, manipulate, hopefully improve it, right? So AI is, well, it's multiple, covers multiple fields. It's not only interested in understanding intelligence, but also it wants to create intelligent entities. We can call them bots, machines, robots, whatever you want to call them. There's many subsections, right? We call them entities, right, for now. And of course, we want them to be safe for us, right? Effective, right? And it is probably, well, I would not be boasting that this is the most rapidly growing field. And remember, this book was written in 2020 when the field is already growing, but GPT-3 and GPT-4 were yet to come. I imagine next year there will be a new version of this book, so it will cover the latest advances, right? Again, it is, if we ever achieve general AI, well, that will be an amazing achievement. But already, you guys already have seen this in person, using for your homeworks, for your classworks, for your learning. I think most of you have used already some AI tooling, right? Even translating things, right? It's already amazing advancements. At the same time, I would not say we do not overestimate things, right? Again, we'll see that AI has a history of sometimes stopping at some moments. There's been some AI winters. We'll talk about that. Now, so plenty of room to explore. Huge field. There's a huge diversity, right? Pretty much anywhere you need some intellectual task, you will have an opportunity to use AI, right? And so it is one thing I want to reiterate, it is interdisciplinary field. So we are coming from computer science, but it also covers mathematics, but also psychology, linguistics, neuroscience, other things, right? Business, right? Pretty much anywhere, pretty much you can squeeze in a usage of AI from many fields, right? But even the nature of AI by itself is interdisciplinary, right? So how do we define it, right? So, well, we want to make computers basically act sort of, well, not I wouldn't say humanly, but do things which generally would require human intelligence, right? So the joke is that as soon as AI starts to do something really well or better than humans, we don't call it AI anymore, right? computers play chess really well, much better than humans, much better than Magnus Carlsen, right? But we don't really sort of like it's okay, it's boring right now. AI in the last 4 or 5 years has been doing some amazing things which were until recently were thought to be the one of the highest goals of AI, but right now it's considered like nothing special basically, right? So but AI well seeks to replicate human thought processes. Again, sometimes there are AI works differently from humans, right? So there's a big ongoing discussion whether AI should be sort of like, can we mimic what humans do, or AI should be using some other approach. As we will see, there are competing approaches, right? So we want to develop systems that act rationally and logically, right? So basically we are developing rational agents which achieve some goal, whether it could be doing your homework, playing a chess game, sending a man to Mars, maybe sending a robot to Mars, right? So again, there are some goals generally, right? If it's goalless AI, well, that's not really what we want to do, right? So we want to also, of course, do it that it's actually beneficial to humans, right? So again, lots of aspects, right? So the goals of AI: understand human intelligence and create intelligent entities. But form, this is very open, this is very vague at the moment, right? Concept intelligence, right? So now, lots of subfields. Of course, the hottest one, which one is the hottest one? What do you think? Well, machine learning, maybe more specifically, deep learning, right? So machine learning is algorithms that improve automatically through some data. So something we feed in some data and machine, the computer, right? Actually, you don't have to write explicit instructions. Now, deep learning is I could say the hotness, right? Uses usually artificial neural networks to learn from experience. So it is a subfield of machine learning, which itself is a subfield of AI. Now, computer vision, for example, important subfield, it could be using machine learning and deep learning, right? For example, NLP, natural language processing. Well, it's a subfield of linguistics, computer science, and AI. So they're overlapping. If we were drawing Venn diagrams, well, we would be, we could be, we have a lot of diagrams. Again, today I'm not going to be using my favorite tool, Paint, but I could be using that. Now, maybe I'll have a picture here. Robotics, another interdisciplinary. By now, you should be getting the feel that this is always you can be pretty safe and say, okay, this is interdisciplinary field, right? Meaning multiple things like robotics. You have AI, which is part of computer science, but you also have engineering, autonomous vehicle, right? Again, compared to just any robot, autonomous vehicle, of course, is car. It could be also maybe you could say vehicle could be a plane, right, or drone, for example, right? Again, game playing, classical field of AI, right? How to play games. Theorem proving, very hot field right now actually, due to actually recent advances, right? How to prove different type of theorems. Expert systems, that's something. It's been around for a while now. Let's say ChatGPT, you can say it's an expert system, but of course, I think it goes way back than that. It basically tries to emulate decision making. It gives you advice, right? It makes decisions, right? Whether we take those decisions, that's up to us, of course, right? So, mathematics, probability theory, statistics optimization, psychology, linguistics, neuroscience, philosophy, economics, control theory, cybernetics, and many others. So how did it all arise? Again, I'm sorry if I'm going very quickly, right? It goes down, we can go even get back to our caves, but Aristotle, he pioneered, right? Teacher, how did it go? Teacher of Alexander the Great, right? He pioneered formal logic, right? Famous rule: all humans are mortal. Socrates is human, therefore Socrates is mortal. Well, unfortunately, he's gonna die, right? So not just general inference rules. Again, you'll see that AI has tried to follow these rules. An interesting next person, Raman Lull. This is from the book, by the way, right? This is all this material. If you have access to the book, all this material is in the book. This philosopher from 13th century, he was of course, he worked in, he had religious connections, of course, in those days, Franciscan, right? Maybe, again, for the famous optional report at the end of the semester, maybe somebody wants to do a report on this person, right? A logician, right? Maybe not much is not as much is known about him as the next famous person, this Descartes, who pioneered the mind-body dualism, right? An important concept in philosophy, right? His idea, we can call them, some people call Descartes' mistake, again, is that, well, we have mental phenomena and we have a physical phenomena. Are they related, right? Are actually the same thing? Well, he thought they were different. Actually, there are two things. There was actually basically two things. No, he was a dualist, right? I don't know if he was the first dualist, probably not, right? But he raised the questions: what's consciousness, right? So this is extremely relevant to AI. How do we, if you want to mimic or human cognition, Descartes and his idea of dualism, well, it's sort of like laid the groundwork. So most days, of course, most scientists, of course, think about it, everything is physical, right? Right. So idea was that we can reduce everything to physical, right? It's very influential AI field, right? Can we align that mental states, what is in our head, can this all be just broken down into individual pieces, or just our neurons firing, right? Well, that's a good question. Is that actually true? There are people who disagree, right? So, including myself, I think it's not so clear, right? In fact, we delve into philosophy right now, whether we can say whether physicalism is enough, actually, right? So, if you ask somebody who is completely religious, of course, you will get a completely different answer, right? So the different approaches of this, right? So, for example, David Hume, very famous philosopher, he asked an interesting question: can we justify inductive reasoning, right? So, meaning, if the sun is rising tomorrow, can we say that sun is going to be rising? You've seen sun every day for pretty much forever, right? Does it mean the sun is going to rise tomorrow, right? And well, the thing is, we really can't say it for sure, right? Maybe one day sun is not going to rise. Maybe, that seems like silly example, silly thing to think about. But actually, when he makes a very good point, actually, we can't really completely justify. We can just sort of, well, make it up as we go, basically, right? We sort of depend on it, right? Otherwise, our world would break down. So why is it relevant here? It's because when we learn some rules, right? There's a famous saying: there are all models are wrong. One of my favorite sayings. But some models are useful. Basically, we're building models. We are predicting something, right? So AI usually learns something from the world, right? From the data we give it, and is it going to be enough? Well, it might not be, right? Again, just like sun might not rise tomorrow, right? Just as long as there might be complete cataclysmical event tomorrow, right? And we don't have sun tomorrow, right? We all perish, maybe. I don't know, but it's not. We still have to work with this, right? So now, logical positivism, right? There are different theories on this. So now. Also, going down to ethics, there's utilitarianism. Sorry, pardon my French. Idea is that AI would be working to create a greater good, right? And some of you have played the game I mentioned, the famous paperclip game, right? You say, okay, paperclips are good, right? Well, in ethics, you may have heard of trolley problem, right? Where a trolley goes down, right? Trolley problem. We'll talk about this later on in the course, right? You've probably seen some images, right? Right? Where you have to make a choice. If you're a tram driver, you are going down the road. You see 5 people laying down. You have a choice. You can actually go down the road and kill one person, right? Sounds very morbid, right? Unfortunately, that actually sometimes the real-time scenario, right? And of course, there's millions of different variations, lots of them silly ones. It's a fun mind problem, but for AI it's very actually useful. Well, because, for example, if you are doing AI on, for example, autonomous driving, your Tesla, you're trying to work on Tesla, for example, right? Do you make a decision? Do you kill the driver of the car, or do you to save the passengers, for example, or do you save the people outside, right? If there's a crash incoming, what do you do, right? So this is actually utilitarianism comes into play. Sometimes there's other theories, of course, right? So AI and philosophy actually is very, very closely related, right? So, oh yes, here's my favorite. Yeah, so this is a trolley decision, and also if you want to play around with this, there's a moral machine here, MIT, right? I think it still exists. You can play around with this, start judging, right? You can start judging here, right? What should a self-driving car do? Right here, right? So I think this was the issue. These are all non-healthy people. These are very healthy people, right? So do you change, right? No. So this looks not. This means you kill these people or you kill these people, right? These are seem like these are healthier and these are not so healthy, I think. But this is about even, right? So do you change? Again, you programming in AI, right? So very interesting on what people think, right? So you can want to play around with this. Again, today I'm not going to do it, but you should do it at home, right? So let's go to other fields which are important for AI usage. Mathematics, formal logic. Again, since we are creating rules for our AI, right? So we need some grounding in formal logic. Also, probability. Again, we are not sure of anything actually, right? 2 plus 2 is 4. Yes, that's true. But as soon as we start making something useful with AI, we are getting into probability, right? So statistics, which goes together, often goes with probability, and of course algorithms on Gödel's incompleteness theorem, right? There are some limits what we can do with basic formal systems, and again some things are just not easily solvable. NP completeness, again, algorithms course, which we took, some of you took last semester, some of you took before, right? Also comes into play. Economics, again, rationality, right? AI systems often incorporate these economic principles, right? Here you can see the marketplace, right? This field of invisible hand, people are trading, and in the end everybody benefits, right? You don't make a bad trade, you make a trades which benefit both sides, hopefully, right? But of course there's lots of distortions to this free hand of economy, right? There are other opinions how should economy work, right? And also bleeds into AI, right? Decision theory, game theory, multi-agent systems, operation research, market decision process. These are all topics we will be covering in the course, right? So neuroscience, right? A lot of it's kind of funny that neuroscience, the big advances in the deep learning have come from really basic neuroscience from 1950s, right? The neural networks, which we'll talk late in the course, are based on some really, I wouldn't say bad or erroneous ideas about or brains, but limited, right? And it turns out, even with really bad, wrong, I would say, quotes, wrong models of our brains, you can make some advances, right? So the push has been to actually use more up-to-date neuroscience to improve AI, right? There has been quite a bit of improvement. We'll talk about this. Also, lots of ideas, interesting things about can we be cyborgs, right? Can we do a brain-machine interface, right? If you are paralyzed, you're very interested in this. There's been some advances lately in this, right? So, if you have maybe you're blind, again, maybe you can have artificial eyes, right? Quite a bit of this is a very developing field, right? Goes also, of course, biology. Also, you go into psychology, right? Because how we perceive things, very influential field, well, subfield of psychology, or maybe I would say not subfield, but the era was behaviorism, right? Meaning there was in mid 1950s, 60s, it was dominant field, very influential. The idea was that basically we learn from environmental feedback, just like organisms learn from stimuli, right? So you might have heard of B.F. Skinner box. Maybe let's do that, Skinner box. You might have heard of this one, right? Images like, right? And you can sort of make poor rats, right, or poor mouse or poor mice. Well, you can stimulate them to do things, right, to do things by different stimulus, basically, right? And they do things where, a lot of experiments in behaviorism, right? And this also led, of course, quite a bit of advances in reinforcement learning, right? So you give rewards, sugar, right? Sugar or sweets or whatever, right? To computers work similarly, actually, right? You may have, of course, heard of tricks in ChatGPT. You say, you will be fined $100 if you get the answer wrong or if you write bad code. It's kind of seems like a silly trick, but it actually works sometimes, right? Sometimes, right? Yeah. So lots of psychology, very important in a field of AI, right? Also, things such as intelligence augmentation. I recommend watching this YouTube video from 19. This video is actually from late 1960s, called "Mother of All Demos," where Douglas Engelbart, well, he proposed things which we take for granted: mouse, a video interface. I wouldn't say email, but sort of like the way we work today. But this is late 1960s. Then, of course, we get to computer engineering, which is, of course, hardware-related things, like how we make computers, because we will most likely need some computers, right? There's some background in that. Also, of course, we'll need a lot of computing power for things we do, right? There's also a promise of quantum computing. There's a huge potential to increase the processing power. It might solve problems beyond our classical computers. There's maybe quantum computing will go together with our current advances in AI. Maybe it will be the next level. We don't know yet, right? There's also a control theory, right? How to make machines, basically, right? Things like thermostat, right? Cornell's thermostat. You probably have one in your room. We have ones at our campus, right? Basically, if things get hot, you open the window. If it gets too cold, right, you close the window. Maybe you start heating the room, right? You do not need a computer, and you might think it's silly, but there is some discussion whether thermostat is conscious, right? Some philosophers think, okay, thermostat actually is a conscious entity. I'm not completely sure I agree with this feeling, right? But you can make an argument, maybe a silly one, that a simple thermostat without a computer, without a CPU, like something from 17th century, right? Which controls the furnace, like your coal blasted furnace, actually is some sort of, primitive form of AI, right? So, cybernetics, of course, Norbert Wiener, very important, right? So, also things about second and third level feedback, right? For example, stopping cruise ship emissions of sulfate, right? Right. But increasing emissions of CO2, more global warming, right? Famous example is China in 1950s. It decided that there are 4 major pests. Fleas, no, I forgot what the top one is, right? But notice which one does not belong in this picture. Who can, like these 3 look kind of nasty, but what about these poor birds, right? Well, it turns out actually in China in the 50s they destroyed all 4 of these supposed pests, and it led to great sorrow and great suffering. A lot of people died, millions actually, from famine, because the ecosystem was disturbed, right? So same thing with feedback mechanisms in AI and robotics. Sometimes it can lead to very unexpected things, right? Actually, right. So, what else we will need to will cover in this course? Some subfield, of course, linguistics, right? Skinner, again, we mentioned Skinner already, right? Chomsky, which we already seen in some other courses, right? He made a very good critique of behaviorist view, right? That you cannot learn language just by stimuli, right? So he had a different theory, that we have some innate grammar inside us, right? Also, he made this hierarchy. Of course, you know about Chomsky hierarchy by now, right? How different strengths of different languages, right? And so NLP, natural language processing, right, is sort of like, again, it is a subfield or a related field to AI. Now, let's go briefly to some history, right? Some like highlights. These are just highlights. AI, early neural network, really simple idea. People knew already what the neurons looked like, kind of had a really rough idea, laid the foundation. But in the late 1950s, Marvin Minsky, a very influential figure from MIT, built the first neural network, right? It was this very early attempt, right? And, well, it didn't really, well, it was not so powerful because, well, the neural network was really, well, relatively shallow. The computing hardware was not there yet. By now you probably know of Alan Turing, who proposed, among other things, proposed Turing test, which basically is whether a machine can fool, you put a person on a machine behind the wall, or you pass messages to this entity on a group of human judges or a human judge, try to determine by question answer format whether it's a machine or a human, right? Rough, I'm giving you a very rough idea, right? On these days, I think you will say that it's relatively easy to make GPT-based large language models to pass most of these things, right? And now people say, okay, yeah, Turing test was nothing, no big deal. Well, it was a big deal, right? Passing it is actually, I think, it's a big deal. John McCarthy, which some of you will see, or you have seen already, among other things, he invented language Lisp, right, programming language, which is used widely in a field of AI, right, along with Marvin Minsky and Claude Shannon, also another influential figure, made this one of the early conferences for the field of AI. Okay, you need a conference to make an AI, right? To make a new field, right? when you start getting conferences, that means your field is already getting mature, right? So there were very big expectations in early years. People thought, well, hey, we'll solve general problem solver, right? Meaning you'll give it any problem, it will solve it for you. Well, it didn't. Well, it worked. Some example: geometry theorem prover. 1959, it could solve some basic geometry problems, right, on applied mathematical concepts. I mentioned already Lisp, which was used for many early AI programs. There's the idea of microworlds. Basic idea was to create a simplified version of our, well, an extremely simplified version of our modern world, and to test it, right? So you make these sort of like fake worlds. Well, you can think of not I wouldn't say games, right? But you can test your algorithms in a controlled environment. Perceptrons, basically an early neural network, showed the machines could learn from data. People thought, well, AI is the future, but then there's dose of first dose of reality hit the first early, I would say, first AI winter. Realized that things we were not getting, the promises were not coming true, right? We basically did not understand. It was the hardware was inadequate. People underestimated problem complexity, right? So the task that humans found simple, right? Finding speech, recognizing speech or images, turned to be extremely complex to replicate in machines, right? So this meant also that basically, funding dried up and, well, things were not happening. There were some other things happening before the next boom. People start developing so-called expert systems, right? Basically, you have some data, right? You could call it database, right? And you could do inference, right? For example, Dendral, one of the early systems, early expert systems could infer molecular structures from mass spectrometry data, right? So a very interesting thing. So expert system R1 in late 1970s was able to configure orders for new computer systems, like something for like build your own PC. But of course, those days this was for mini computers, right? So first large scale, or one of the first ones, right, which demonstrated that you can actually do something with AI. And then there was Japan's fifth generation project. This was a huge. Japan in those days, 1980s, was you could say the next great superpower after America, USA. People thought Japan would overtake America shortly in 1980s. It did not happen, but as part of this growth, was increased funding, government funding, to revolutionize to AI basically, right? Idea was you create some computers could carry tasks requiring human intelligence. Again, there was huge promise, right? On neural networks made a return, right? This has been the big advance, basically. Slowly, people realize you need more connections, you need more data, and there was something called backpropagation algorithm, a relatively simple idea which allowed neural networks to adjust their learning. And along with that, we got a nice little extra with increase in computer power, meaning or computers basically you need for algorithms to get better results. It turns out you need more computing power, right? So more this led to more deeper learning, right? We must go deeper. We could learn, we could create more complex neural networks, and we start getting some practical results. Next big boom, well, machine probabilistic reasoning, right? There were different approaches. People tried to have different networks, right? But machine learning was probably, I would say, the most making the biggest how to say advancements. I want to go next, which is next big the state state of the art, right? So but hard thing was XKCD image recognition, right? This is one of the famous comics, right? And this is from again when a user takes a photo, they actually take a check whether they are in a national park, right? And check whether the photo is of a bird, right? On this comic, XKCD has been around for about 20 years. This was like in 2010, 11, roughly around then, or 9. On at the time, this task, right? I think it mentions here, if you mention here, if I cover, right, Marvin Minsky, which I mentioned you before in this class, that this was how to identify objects. Object recognition was a hard problem for 50 years. And then in 2012, what happened? AlexNet, a deep neural network, made a huge leap, right? Because at the time people were trying different approaches, but this idea that we can just feed a lot of pre-labeled data and get models which are still wrong, but they can be very useful, right? So start getting increased. So basically more answers, more data in, right? We start getting better answers, right? Basically that was a big thing, right? We start getting also interesting things like BERT and also transformers. That's probably been the story last 6 years since publication of crucial paper in 2018, right? So a lot of advances, right? You might have heard of AlphaGo. One of the chess was beaten by AI tools in mid 90s, right? World champion Kasparov lost to Deep Blue, but AlphaGo beat the human champion in a complex game of Go, which was thought that this would be the game which would be, how should I say, would not be solvable easy. Humans could still stay ahead of computers, but turns out this game actually also was well, I wouldn't say solved. No, computer-based agents are better than humans, right? So there are very few games remain these days where humans can still survive, right? So another tendency has been generalization, right? What works in one field, let's say medical diagnosis, it might work in financial forecasting, maybe, right? So what works in programming for one thing, maybe works for something else, right? So state of art, right? Right now we are, I would say, third boom. We had a couple of AI winters, right? Now there's this idea of general AI, meaning which could be able to do anything, right? Well, ChatGPT is not there yet. Not actually. Some people say this is. Some people think it's a dead end. Oh, I don't say it. I personally think it's gonna transform-based models will be part of a solution, not the solution. There will be need some other things. There's increase in AI students among you yourself, right? There is generally positive. I don't know. That's kind of changing right now. some people are realizing the dangers, right? So there's a huge diversity, lots of conferences, good stuff happening, high speed, right? There's some people think there might be sort of like explosions one moment when AI really makes the next jump, right? Becomes smarter than us. Well, we can say, okay, it's already in some fields, AI is already smarter, right? But notice AI systems are increasingly meeting or surpassing human performance benchmarks. So people like the critics say, okay, yeah, it's no big deal. We'll do the next one, right? So it's still very, 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 well, it could be a discussion. Are we early in this boom or are we late? Is it going to be next AI winter, right? We don't know. We really do not know at the moment. So, we have huge, but hopefully you can see that why we should study this field is there's huge potential for benefits, increased efficiency and automation, advancements in healthcare. Again, even thought I spoke with a doctor in America yesterday who was complaining that the AI assistant is trying to give advice on diagnosis, and she says in America, she's afraid of lawsuits, right? So she says, she's afraid to give diagnosis which is different from the computer diagnosis, even thought she has that power, right? So, very, very tricky question now. What happens when there's a mandate to take the AI diagnosis, right? So, who 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 pays if the diagnosis is wrong, right? Which inevitably, again, all models are wrong. It's just some of them are very useful, right? Some of them are more accurate than others, right? So, lot of potential, I would say, food guns, right? But again, so risks I mentioned already, right? Are we gonna get into robot wars, right? Terminator-ish scenario, right? We see what's happening worldwide, right? So also uh, unemployment concerns, right? This has been goes down to Luddites, 19th century. There's automation, right? There's economic disruption. People actually lose jobs. It's happening. If you are a very average artist, you probably don't really have much of a career prospect anymore. You have to be either really good or you have to use AI tooling, right? So also, if you're a very average writer, again, not much of a future here. Or if you are average translator, right? Again, very, very non-shrinking field, right? So I will give you a backstory on photography, right? Well, on a painting in 19th century, there was, up to 19th century, people painted portraits, right? It's a normal thing, right? And once photography came on the field, 19th century, of course, painting of pictures of people, well, it was basically just an extreme luxury now. It was not like a normal job anymore. Very few people uh, paint for profit, basically, these days, people, right? So, you can do art, that's different, right? But you usually take photos, and of course, now regular photographers also suffer because of we use mobile phones. That's another story, right? So, yeah, so there's lots of different risks. So, as I say, we live in very, as an ancient Chinese curse, we live in very, very interesting times. Okay, yeah, there's this comic which I mentioned already, right? So we live in a very interesting times. So again, uh, we'll see by the end of this course, we'll have some new advances. I should mention this. So, out of all of this today's topic, I recommend you go over to maybe a little more in detail than I did, right? But just give you the taste. Next lecture on Thursday, we'll start talking about intelligent agents. How do we define them? What can they do? What's the idea? Now, also for fun, you can see the far. There's some AI resources, right? I mentioned here, right? AI news, right? Like especially AI advances in 2024. I recommend saying this is a pretty nice link here, right? Some of the things that happen here. Also, maybe 2033, right? Again, you might want to read about that. Again, so for Thursday, you do the quiz, of course, as usual. You do the quiz for this chapter, and I'll see you on Thursday. Thank you very much.